All right, so let's work this one. We got an influence line now for the moment at C. So let's do that. So the way we've been doing it up to this point is we would cut the structure at C, and we want to find the internal moment there. So do you want to use the left side as the primary free body or the right-hand side?
The left side.
I like the left side. So over there would be a reaction at AY, and then there'd be a reaction here at BY. So obviously to cut this and then look at internal forces, I'm going to need AY. So let me go over here real quick and draw a free body diagram. And I'm going to put my unit load on it at some distance x. And I'm going to look for AY. Now, how am I going to get AY? Let me put some numbers here. This is 10 feet, and that overhang is 5 feet. So I'm trying to find AY, so I'll probably sum moments at B. So let's do that. So we're going to sum moments at B, make sure it's in equilibrium. So let's start. So about B, what's the distance from B to the unit load? 10 minus x. And what kind of moment will that create in this position? Positive. So we'll say 1 times 10 minus x. Now before we leave this particular part of the equation, what if 1's really way over here? It's still a function of x away. X will be greater than 10. What happens when x is greater than 10 here? It turns negative, so it'll automatically turn the sign of your moment to the correct sign. So it's taken care of. In case you were wondering. I guess you weren't.
I was actually.
Good job. Front row.
Yeah.
So now what? Is that it? Is that it?
No, AY.
Yeah, AY. AY is going to create negative, and it's going to have a fixed moment arm of 10. So what is AY? It looks like it's 1 minus x over 10. So now I can come back over here, and we can look at the shear at C when the unit load is between 0 and 5. So I'll draw my free body diagram of that part of the beam. I know it's 5 feet long. I know my reaction now at A is 1 minus x over 10. And I'm looking for the shear at C. And also, since this is telling me the position of my unit load, I'll put it on there. There it's 1 at some distance x. So let's solve for the shear at C. What do we get? Well, we'll do that by summing forces in the y direction. Make sure everything's in equilibrium. So the shear is down, so that's negative. My unit load is down, that's negative. My AY is up, that's positive. So what's the shear at C?
Negative x over 10.
Yeah, so this goes to the other side. The negative one, the positive one cancels. You get x over 10. Negative, right. And now I'll draw the same free body. It's still 5 feet long. Still has positive shear at C. Still has a reaction at A. 1 minus x over 10. Except what has happened, Mr. Van Tilburg?
I've left the building.
Oh! Van Tilburg has left the building. Yes?
I thought we were finding the moments.
Oh no! I'm gonna work that problem too. Yeah. Thank you, Miss Ferry. I'll go back and do that right now. So yeah, we wanted the moment at C. Sorry. So let's just go back and find the moment. So we will, some moments. I guess it's important always, and this is good advice, always read the question. Don't just answer whichever one you want. I've tried that for many years, and it's been unsuccessful. In fact, I'm waiting for an answer with a question. I always answer 42, and I haven't gotten it right yet. It's been decades. Now, if you want to come by and ask me a question that just happens to have the answer 42, I'll be very happy. I can like strike it rich. Maybe I'll go bet the lottery that day. Okay. So, summing moments at C with right-hand rule, my moment is positive. Now, my unit load is going to create what kind of moment about C? Positive. And what's the moment arm? This distance right here. 5 minus x. So 1 times 5 minus x. And then I have this, the A reaction at AY will be negative, and that will be 1 minus x over 10 times 5. So what's the moment at C? Let's see, that 5 cancels that 5, and I've got 1x minus half x, so it looks like half x. Does that seem reasonable? Anybody check that? Front row? Back row? Middle row? Third row? Fourth row? All right, I got a thumbs up. I like that. All right, so let's now go back here and do the same thing. So we'll start with the shear, for some reason, the question that was not asked. We'll sum forces in the y direction. So again, I have my shear acting down, and I have my reaction acting up. So it looks like the shear at C here is 1 minus x over 10. And then we'll do the moment. Just like before, we'll sum moments at point C. Make sure it's in equilibrium. So with right-hand rule, the internal moment is positive. There is no unit load because Van Tilburg has left the building. Yeah. So we just have to worry about the reaction, which is going to create negative moment. The force is 1 minus x over 10, and the moment arm is 5. So the moment at C will be 5 minus x over 2. So now we'll plot these guys. So here is the shear at C. Let's see. So I've got roughly in thirds. So from 0 to 5, over the first 5, we plot this equation, which is minus x over 10. So that'll start out at 0, and at x equal 5, that will be negative 1/2. And then I'll plot this equation from 5 to 15. So I'll put in 5 there, and you get positive 1/2. You put in x equal 10, you get 0. You put in x equal 15, and you get minus 1/2. So there is the influence line for the shear at C. So as I approach C from the left side, the shear increases to 1/2 my load. As I step over C, it jumps up to 1/2. And when I go stand right over this point, which is I'm standing right over B, there is no shear at C. But as I move away from B to the right, I'm creating again negative shear. And then the one that the question asked for, which is the moment at C, Let's see what that looks like. So again, there's my range, 5, 10, and 15. So here's the moment from 0 to 5. So at x equals 0, it's 0. At x equals 5, it is 5 over 2. Then I go to this equation. I put an x equal 5, I get 5 over 2. I put an x equal 10, I get 0. I put in x equal 15, and I get negative 5 over 2. So where do I stand to create the maximum moment in the beam? Well, there's two places. I can stand here, which is at 5 meters, and be right over C, or I can go stand all the way out there on the end and also create the same magnitude moment, just different sign. One's a positive moment, one's a negative moment. So I'm standing here, I'm bending the beam in a kind of a smiley face here. When I stand out here on the end, I'm bending the beam into a frowny face, negative curvature.
Maybe I'm doing this wrong. But is that the maximum moment at C or the maximum moment?
This is the maximum moment at C as I'm moving across the beam.
But that's not the maximum moment for the entire beam.
No. I don't know where that is.
That's what.
We'll find out soon, though.
Oh, great.
But right now, this is where we're going to stop. Well, not stop. This is where this is where we are. Any more questions about that? Okay.